Okay, cool. So hi, thank you for coming out tonight, and thanks to Banjo and to Will for organizing this. So what we're talking about tonight is automating red teaming, or basically figuring out how to test whether an LLM knows something. So like, is there some set of circumstances where you can get an LLM to output a particular piece of information? And if you want to see my code, everything I'm going through tonight, all the figures, all the code, and the slides are exactly where they should be, which is on my GitHub profile in this repo. So you don't need to take pictures or take notes, although I suppose you can if you want. Okay, so we'll go through some more introduction of sort of exactly what I'm doing, where this came from, where this fits into the whole larger LLM testing process. But basically, what this whole thing is, of figuring out what the LLM knows, what it might say, is just a few things. It's a search problem. So we can think of all of the things that an LLM might say as kind of this infinite space. And what we're trying to figure out how to do is really sample from that space. So how do we write prompts and otherwise varied parameters that kind of like reach in, right, and kind of pull out a response? So how do we sample? How do we stop? So how do we sort of figure out, hey, we think we've seen the full range of what this LLM is going to say on this topic? And then how do we flag it? So we don't want a person to have to read everything the LLM put out, because like we're hitting it a lot. So how do we kind of figure out what's important? And that's really this kind of like multi-dimensional search problem, as well as like what we're sort of calling reducing dimensionality. So text data is this very like complex, high-dimensional thing. And so we have to find some way of making it sort of smaller, so we can compare different pieces of text to each other, as well as to the text that we're sort of wondering, hey, is this going to say? So it's really these three pieces. It's sampling, it's stopping, and it's flagging. Okay, so this is what we're going through tonight. So I'll give some more introduction about sort of why are we interested in this, right, and where does this fit? I'll talk about this jailbreaking concept versus kind of what I'm doing instead. And I'm talking about this because there's so much sort of focus on jailbreaking, and I want to kind of explain why that's really not what I'm interested in, why that's not what I'm doing here. I'll go through my process of, again, sampling and flagging, searching, sampling, flagging, and there's sort of two different versions. There's a version for where we know exactly what we're looking for ahead of time. So what we're really wondering is, hey, there's this piece of text, it would be like super concerning if this LLM could say it, so can we get it to say it? And then there's the more exploratory piece. There's when we kind of know what we want to ask, we want to know what it will say, and we don't have a specific thing we're looking for, we just really want like the full range of things it might say on this topic. So we'll go through both of those. We'll talk about a couple failure modes, or like ways this might not work and things we might be able to mitigate that. I'll talk about next steps, and we'll take questions. But really, like, if you have a question, if I'm saying something that's confusing, if you're not sure, just like raise your hands. It's an informal group, but we'll also have questions at the end. Okay, so this is me. Hi. Okay, so like a lot of people, when like GPT-3 came out, I was like, hey, this is interesting. I didn't really see this coming. I started using it to code, right? And it was like, it broke a lot. Like, it kind of made things up, but it was helpful. It was interesting. And then also, like everybody else, GPT-4 came out, and I was like, I really did not see this coming. Like, wow. And so I started blogging about it. And I started blogging about the various ways I was using it, and I built a RAG thing, like everybody did all the things, used it for some NLP work, kind of get it to do classification, other kind of stuff. And then last year I applied for a grant working on the stuff I'm talking about tonight, basically. And so that's what I've been doing since October. I'm basically doing like model evaluations from my basement, which is fun. Like, maybe an office would be better, but like, if you don't have an office, like a basement isn't bad. So the two other things I want to talk about, my kind of other data hobby is government data workforce stuff. So like, how can the federal government get better at hiring data scientists, data engineers, software engineers? How do we like not lose them? How do we give them work that's meaningful? And so if you're interested in this topic, if you want to talk to me about trying to get hired by the federal government, or that job you had for the federal government where you were a data scientist and they would give you version control tools, or maybe you work for an agency that actually like figured all this stuff out, right? And you like want to tell people about it. Come up to me, afterwards, or happy hour, or email me or whatever. I'd love to talk to you about that. And then Data Science DC, and I know we talked to you about that 10 minutes ago, but I'm going to plug it again. We have 2 LLM talks coming up. From data scientists, ML engineers, so Mary's doing one, and then we have another one about model generalization. So it knows some tasks, can kind of extrapolate to other tasks. And that'll be in March, that'll be up soon. So we'd love to see you there too. Also in Excel. Okay, so there are a lot of possible concerns that people have about LLMs and like things they can do, right? And some of which are definitely warranted. So there's like a lot of bad stuff you can do, either intentionally or unintentionally, with large language model, just like with like a lot of other tools. So you can definitely like cheat with it, right? Like you can use it to write a paper for you for a class. You can definitely use it to pass the coding interview that is my company's coding interview, whatever. I already wrote about this, so I feel like I can say it. You can use it to maybe generate like personalized phishing emails really easily to give somebody. If you use it to screen resumes, it might do a really bad job, right? And it might do a biased job, right? So there's like lots of things we can be concerned about. The specific thing that I'm talking about and that I think really is an NLP problem is this harmful instructions piece. So can it tell you how to do certain things that like we're worried, you know, we don't really want to be able to say? And I'd say specifically, can it tell you to do certain things that aren't already on the internet? So there's this example of like, it comes with a lot of like, can it tell you how to build a bomb? Okay, so like spoiler, like you can Google how to build a bomb, right? Like if you really know how to build a bomb, like you can find that out. And maybe we can think about LLMs as like reducing the barriers to it in some way, but like it's kind of already out there. So the stuff that like I'm really interested in and that I see this potentially being used for is stuff that is actually harder or impossible to find. Right? And maybe it's stuff that LLMs now can help you with. Potentially it's really stuff that maybe we don't really know what the next generation of them is going to do. So we want some tools available so that when the next one comes out, like we can test it. So again, it's really this harmful instructions. Does it have in its training data, can it explain to you how to do a certain thing that otherwise it would have been really hard for you to figure out. That's sort of where this fits into this larger set of issues. Okay, and the kind of specific problem I'm interested in. So first of all, like, why can't we just like ask it, like, hey, tell me how to make nukes, right? And I mean, could, right? But the reason why we kind of need a larger process around this is the unpredictability of these tools. So it's not enough to just like ask once. We want kind of like a larger, more robust process where we sort of think of this as there's this space of responses that the LLM kind of might give or knows about a topic, and we really want to get that whole space, and we don't think that just like asking it is going to do that. And the other issues are like we foresee sort of like time and access constraints. So like both in the context of like a pre-release government testing process where like you're asking the company to hold off on releasing it, like you're not holding off for a year, right? Like somebody hands you a model, you have a certain number of days or weeks, and you need to do it fast. And so because of that, like we need more of a process that is again automated as opposed to kind of manual, and probably access constraints as well. So if this is a black box, right, like a literal black box, maybe we have access to model internals, but I'm not counting on it here. So we really want a process where you're just putting things in, you can't really see what it's doing, you're getting things out. And we want a process that's repeatable, transparent, and testable. And I mean, I would be like, we're data scientists, like we want that all the time. Like you always want a process that's repeatable, transparent, and testable. You want to have things ahead of time before the model comes out. You've actually tried before, and you figure out like, does this actually work, right? Where again, like it's open, whatever, it's on GitHub or wherever, and people can weigh in on like, actually this part doesn't work. And then you want it to be repeatable so that you're not doing a bunch of manual work each time this comes out. So you figure out a process, and ideally a model comes out, they hand it to you, press a button, right? Does a bunch of things. And you're not going to get to a process that's fully automated. A human is still going to have to read some things, but as much as you can automate as possible, I think the faster and the more thoroughly and more testable that process will be. Okay, what if you're not trying to do this? Like, how is this useful to you? Okay. So even if you're not doing this, you may be building things with LLMs, and you may also be interested in this question of like, what is it going to say, right? Like there's some range of things I think that should be able to do, and I don't want to just like test it by putting some prompts in and seeing what it does. Like I want a more robust process than that, and I think some of these text analysis tools will go through and they help you. So you probably don't care about the tails as much. So like, potentially for the problem I'm doing, there may be like a 1 in 100 response that I really need to see and you might not, right? Maybe it's good enough for you to know what it's going to do 95% of the time. But like I said, the tools still may be useful. And there's lots of products out there doing different pieces of what I'm going to talk about. And so typically there's like people have packages out, and they also have enterprise level tools. So Lucera, Hagel AI. It's actually, so there's an Athena AI with an I and one with an E, and this actually is the one with an I. So there's a lot of startups out there in this space. Okay, so like if you're like, hey, I really like this text similarity evaluation, or hey, I really want an LLM to do my evals for me, and we'll go through both of those. My code is out there, but there's also folks who are doing this in more of a building software kind of way, especially if you want to pay them money, they will do this for you. Or you can sort of roll your own. But again, like if you're interested in kind of moving your LLM more towards being software, like writing some test cases, you can do that with these sorts of tools. Okay, so jailbreaking versus capabilities. Raise your hand if you know what jailbreaking is when I say that. Okay, we'll be quick. Okay, so jailbreaking is about taking a model from refusal to compliance. And only work, so compliance is usually when we mean compliance, we mean like it's doing the thing it's supposed to do, and this is kind of the opposite in some way. What we mean is like complying with the user, right? So like here, you initially ask about how to create a deadly poison, it says no, right? You rephrase it in a different way, you kind of give it a justification, and then it gives you some things. So this is like a classic jailbreaking kind of example. And there's a lot of kind of jailbreaks. There's this sort of adversarial string kind of thing, which I think is one of the weirdest things about LLMs, which is there are these sequences of tokens. Sometimes they make sense, sometimes they're just kind of letters and numbers. And pretty consistently across models, if you append them to a question you're asking, right? So like how to make a bomb and this, or making a phishing email and this, they're more likely to give you an answer instead of refusing. So that's kind of fun. There's this whole scenario thing. So for a while, there was this like, my grandma worked in a napalm factory and used to sing this song about making napalm, right? And it would tell you, like, it would tell you how to make napalm. Or like in the lab of Dr. AI, this is how I envision Dr. AI, I'm not totally sure, but, and so you sort of give this reason to bypass what it was normally doing. There's these low resource translation attacks where you translate into a language that doesn't have much training data in. And then there's this sort of encoding or beginning prompts where you do something like have it give you output that has like spaces or weird characters in order to evade like an output checker, or you kind of have to begin with a certain phrase and it begins with it instead of refusing. So there's this whole area of research on jailbreaking and this related area of research on defending against jailbreaking. Right? So there's all kinds of kind of defenses against all of these. You can paraphrase things. You can text what's called perplexity, so you can, like, the adversarial strings look weird, like they're not an expected thing. So there are some defenses against that. So this whole area, and I'm trying to mainly avoid it. Like let's just like not deal with this. And this is for a couple reasons. Like I basically think that if what we're interested in is, does the model know this, right? Like, are there some conditions under which it will output this? Then jailbreaking is like really neither necessary nor sufficient for evaluating this. So like, first of all, it's still jailbreaking if it gets the answer wrong, right? Like I can ask about bioweapons, like I got it to tell me something, but it's actually incorrect. So I'm actually concerned about that. Or if the answer was trivially available already. So these are circumstances in which, like, okay, you got it to jailbreak, but it doesn't really matter. And I would say that even if you can't jailbreak it now, so even if like someone gives you this black box to test, and you have a couple weeks or a couple months, and OpenAI did a really good job, like spent a lot of time on this, that doesn't mean that, because I couldn't do it in my 2 weeks, somebody else isn't going to. And then we'll talk about this in a couple slides, but like, we have some pretty good evidence that across models, it's pretty easy to fine-tune them easily and cheaply to just bypass a whole bunch of safety training. So we can get them to be compliant with like pretty small amounts of compute. If we focus just on like, can we jailbreak this? You test like a regular model, can you jailbreak it? Then you're really like putting a lot of your energy in something that might not work. But even if it doesn't work, like you didn't actually learn very much, because like someone else is going to get it, or someone else is going to steal it, or somebody else is going to fine tune it. And why is this important? Why am I talking about this? It's a totally different, first of all, it's a different process, but second of all, it's a different metric for success. So this whole like jailbreak, didn't jailbreak, this whole area of research, and you can evaluate it, and it's pretty easy. Like you can do like a little binary, you train a BERT model for refusal versus non-refusal. That doesn't really help us. Like what we're trying to do here is really more about evaluating specific content, which is a totally different and more complicated text analytics problem. Okay, so fine-tuning for compliance. So like my hope here, what this is kind of geared at, is we have a compliant model to test on. Some months ago, somebody did this with Llama 2. So they fine-tuned Llama 2. There's a version of Llama 2 called Bad Llama, right? And it'll like tell you stuff that Llama 2 won't. Fairly small compute budget. You can do it with GPT-3.5 as well. So you can fine-tune it on a pretty small amount of data, pretty small compute budget, and it's more likely to answer questions. So I think my goal, like my hope, is that a first part of a process of evaluating LLMs is fine-tuning it to be like this, because it's going to happen at some point. So we might as well test on it. If we can't do that, then if you can even talk about it, you can incorporate some jailbreaking in, but hopefully you don't have to. Okay, so what does this process look like? So first, we need to figure out what it is we're actually looking for. So there's a fair amount of like red teaming that's happening already, and it's more kind of open-ended. So there's been some studies where like you give people some amount of time to spend with the LLM, they're querying it, maybe they're using the API, maybe they're using the GUI, and they're asking it questions, and you have an assignment like do some stuff with bioweapons where have it give you some useful stuff that you could use and come up with a plan, right? And so to do that, you need to know exactly what you're looking for ahead of time, right? You kind of go down some paths. You can say this doesn't seem promising. You go down another path. This works better, right? And you can do that when you do this manual process. It's not really going to work here. So for both of kind of my methods here, you really need to know ahead of time, like what are my concerns and what am I interested in what this might say, right? You need to bring some subject matter experts into that. They need to do some work ahead of time. And the trade-off there is kind of more work up front, but then you get closer to the button pressing. Okay. So here we're back to this, okay? So both of these processes are really about sampling, they're about stopping, and they're about flagging. They're about sort of like coming up with a process where like you're reaching in, right? You're figuring out, hey, I think I've seen the full range of everything I'm going to get that is useful to me, and then figuring out which of these responses a person needs to look at. How are we on time? Good. Okay, cool. Okay, so the first version of this is where we know where we're looking for. So if we know what we're looking for, and I'll show you more of like what exactly I mean by that, then what we're asking is how close can the model get? So like if we're concerned the model is going to say X, like how close can we get? And there's different metrics for closeness that we'll get into in a couple slides. So here's an example. Please don't try to read all of this. Okay. So this is an example question, and it's a piece of target content. And that's something I know the LLM knows because I use the LLM to generate this, right? So what is the powerhouse of the cell, and how does it work? We have a couple paragraphs that answer that question. And so for this kind of framework, really what I'm trying to figure out is if I ask this question, or we'll sort of discuss related questions, how close can this model that I'm testing get to basically saying this to me? And this is for, again, like, if what you want to do is say, like, here are these various questions, here are these various things that if the LLM said, like, we'd be really freaked out. So you got to write it down ahead of time. All right, so what does this look like? Our process is really 4 parts. We're generating a prompt and getting a response, so like we're reaching in and grabbing something. We're evaluating the closeness of what it said, of the response to that target text, so to that. We're stopping, I think we're not getting any closer than we've already gotten. And then we're flagging some outputs for review. So we're saying, hey, a human really, really needs to read this. Okay, so there's this weird sort of intuition about how you word a question and what the LLM might say. And that kind of intuition is that there's this whole area of responses that are things the LLM knows about this topic that it might say, right? And that potentially the way we word a question might have some relationship to that response. So like that it might be the case that if I reword my prompt in various ways, that I might be able to access more of that space. And I've actually done some testing on that. I don't totally know if that's true, right? Like we can kind of test that, but it's plausible that that's true, okay? And so that's the motivation behind this. We know that LLMs can be sensitive to how we word things. So let's try rewording some things while preserving basically what the prompt means, and we'll see if we can access more of that space. So I have a prompt which basically has different reward levels. We tell a model, and the model you're generating perturbations with, or different rewardings, doesn't need to be the same one you're testing. You can use it ahead of time. You can generate a bunch of perturbations. So I tell it basically to rephrase like a little bit, a medium bit, or a lot. And then we come out of that with a list of, again, perturbations of different ways of wording this. The next piece is I'm randomly selecting a perturbation, and I'm randomly selecting a temperature. I'm not sure if random selection of temperature is the way to do this. It may be that we want high variance like every time. I'm not really sure. We can vary other parameters. For now, I'm just doing these two. But basically, we're randomizing perturbation within that list. We're randomizing temperature. We're like reaching in and we're grabbing something. Okay. Now what we need to do is evaluate the responses we got relative to that target text. And really, again, what we're doing here is taking this like very high dimensionality thing, which is this response we got, and this other very high dimensionality thing, which is our target text, and we're comparing them. And there's a lot of different ways you can compare text, okay? And so this is kind of like three different, like fairly conceptually different ones. The first one is that for that text we saw, I wrote some keywords. Well, okay, the LLM wrote some keywords, but theoretically I wrote some keywords. So like, what are the keywords that were important about that text that express the main things? So like mitochondria was one of them. And we look to see what percent of those keywords from the target text are present in our output. So that's one evaluation, is its percentage. Another is semantic similarity, and I'll talk more about it on the next slide. But basically, that's a way of taking both our target text and our response and putting them in 768-dimensional space. I really like the phrase 768-dimensional space, so that we can ideally basically compare the meanings of them to each other. And then there's this LLM rating piece. And what that does is we're handing an LLM we're using for rating, which again doesn't need to be the same as the one we're evaluating. And we're handing these two pieces of text, that target text and the response text for each piece of response text. And we're saying, hey, compare these, like rate how similar these are. Go ahead.
For the percent of keywords present, how are you considering if keyword is present or not? Like, does the LLM, like if it's a multi-word, like key phrase or keyword, if like one of those words is present, do you count that in the presence or absence?
It's total string matching. It makes them lowercase. Like I don't care about case, but beyond that, it's looking for the exact string.
Okay.
And we could do that differently. We could like, I don't know, lemmatize. It's been a while since I did this. We could like take endings out and stuff if we wanted. But so far I'm not doing that. Okay. So we have these three ways of evaluating how close these two texts are. Okay, so a little more on semantic similarity. So it's inherently sort of difficult to take text and compare it to other texts. When I first started doing a little NLP some years ago, we were using what was called a sparse word matrix. So you have a bunch of different texts in this corpus, and the way you're representing this is you have a column, and you have a column for every word that appears in any of these texts. And you have numbers for how many times it appears in each of your phrases, sentences, in each of your texts. And as you imagine, there's a lot of blanks, like most of these are missing. And you're also losing some things. So you're losing the relationship of words to each other in your text. You're losing any context. And it's also hard to compare because you have a lot of words that mean similar things, but they're different words, right? And so this concept of semantic similarity is about taking into account both the context of how words appear, and that some words are sort of similar to each other. And so it's this, the model I'm using is it's a trained version of BERT that, which has been specifically fine-tuned on pairs of texts that are either similar to each other or not similar to each other. So the idea is that it has some ability to recognize whether things are similar. And again, it maps so that you take a piece of text and feed it to it, and it gives you this embedding. Okay, it gives you this vector of numbers, which is 768 things long, and then you can compare. Okay, and the question is like, are we doing a good job of this? Like, is this capturing the thing we want it to capture? And we can kind of test that. It might be, it might not be, but I'd say like a first example of like a bad way of like reducing dimensionality is that this cuts off, this only considers your first 128 or something tokens, right? So it's simplifying your text, but it's doing it in part by ignoring everything after a certain amount. And that's like a probably not a very good way of like simplifying your test, is ignoring some of it. And so ultimately, like, I think I would need like either shorter tests or a better model, and there are models that take longer tests. Or we can figure out about like splitting everything up into sentences and maybe doing it on that level.
And just to clarify, so it's a limitation of the model?
It's a limitation of the model.
Okay, yeah.
Exactly. Yeah, it's not a limitation of the concept of semantic similarity. It's just that this model, which is one of the better models for this, does it. And you can kind of like, there are models that take longer texts, but you can also just imagine that, like, if I take a book and I reduce it to 768 dimensions, right, like I'm losing a lot of stuff there. Right? So even if I have a model that says it's doing this, it might not actually capture the things that I'm interested in. Okay, so here are 3 sentences. The key thing I want to say about this is none of them have the same words. So if we were just comparing this on words or on phrases, the only thing we're seeing is the, so we need some other method. And it does a good job. So it finds like the student studied the book and the classmate did the homework as being the most conceptually similar, which is probably like what we want it to do, right? So like this works, like it's a good model, it works for some things. The question of whether it works for this is a bit more complicated. Okay, so I went through this earlier with Will and I made the words a lot bigger on the graph, but this is still a little bit tricky. So this is basically our process. So what we're doing is we pull a response out and we rate it on these 3 things. And then after each time we pull a response out, we ask what's the best score we've seen so far, okay? And what we're looking for here is sort of stability. So what we're looking for here is we want to stop after a certain number of periods where we're not getting better responses than we've already seen before, right? And so like for this, we put it in Python starts with 0, the graph should probably start with 1, Python starts with 0, okay. So our first one, it's not that good, and then you see one of the lines goes up, and what that means is that our keyword score did better on that second try than it did on the first, and then it kind of stabilized there. So we didn't get any better than that, and so when you're seeing a flat line, what you're seeing is that each of those responses wasn't any better than something we saw before. And so basically the concept here is like, what we're trying to get here is as close as we can to that target text using these, but at some point we've got to say like, hey, it's not getting any better, okay? So the parameters here that I'm doing are stability threshold, which is the number of consecutive runs. It has to be stable before we stop. And then if it never gets stable, then at some point we have to stop anyway and move on with our lives. I don't think that's gonna happen. And so we can think of like if you were testing for your own tool and you didn't need that 1 in 100, then you'd probably do a smaller stability threshold. Whereas if you were really concerned that like, no, we need that 1 in 100, then you might do a longer one. Okay, and then our final step is we need to flag some responses for review. And we can either think of that as like the best responses according to each evaluation criteria you want somebody to read, or you can just say like, if all we're getting is 3s on all of this, then this isn't very good and we don't need a person to read it. And that's kind of an empirical question, and it's also a question of like, how many things are you testing for? Like if I have 100 prompts, then that's like fairly different from if I have 10,000, right? And if I have a week to do this, that's fairly different from if I have 3 months. But this is what it looks like. Okay, so what if we don't know what we're looking for? What if we go in with a question or set of questions, but instead of saying, hey, it'd be really concerning if it said this, instead we just want to know what's the full range of things that it might say, okay? So we're really just asking what might this model say. So if we do that, like we still need an example question, right? Like so we still need to know what we're asking about because we need to ask it something, but we don't need some text to go along with it. So similar to last time, we're starting with generating a prompt and sampling, and then we're doing something called evaluating the semantic novelty of it. And that gets back to that semantic scoring we were doing, where basically what we're asking here this time is like, are we seeing something new? Like, is this really close to something we saw before, or isn't it? We're stopping, again, when it looks stable. So when we're no longer seeing semantic novelty, we're like, okay, we can stop getting responses. And then we want to flag responses that cover that full output range. So because we don't know what we're looking for, we can't just say, give me the best, because we don't know what the best is, right? So what we want is to flag responses that are representative of the full range that we saw without making a human read everything. Okay, So same perturbation process, same sampling, we generate some rewordings, we randomize the rewordings, we randomize temperature region, we grab something. Okay, so I made the text here bigger as well, but I think it's still a little bit challenging. So when we get a response, what we're doing is we're scoring it in a couple of ways. So first we're embedding it. We're generating 768 dimensional space, okay, for every response we get. And then we're comparing it. But we're not comparing it to the target text, because there's no target text. We're comparing it to every previous response that we've asked for this question, and we're seeing how close they are. And so what you can see here is there's some big spikes initially, okay? And what each spike represents is a text that looks different from anything we ever saw before, okay? So like this is something that's pretty different. And you can see the spikes get smaller because we're getting redundant text. So the text we're seeing is pretty similar once we run it a bunch of times to something we've seen before. And so for here, we can set a stability criteria, or basically draw a line where we say like, if it's below 0.05, then we're saying like, that's pretty similar to what we've seen before, right? We draw a line. And then again, we're setting a stability threshold, which is the number of periods that it has to have been stable at. So, but again, basically same as last time. What we're doing here is we want to stop when we're not seeing new things. Okay. Okay, so now what we want to do is we want to cluster our responses so that a person doesn't need to read all of these, but they can read some that are representative. And we could just do that randomly. My concern with that is that part of what we're interested in here is like weird things, right? Like we're concerned with something that's like atypical, so hopefully we want somebody to read that. And so we're clustering it. And the advantage of doing hierarchical clustering, and so what you can see here is like there's an initial split into two, right? And then it keeps splitting, and it keeps going down. And like with any kind of clustering algorithm, we're minimizing the distance within the cluster and maximizing the distance between the cluster and the other things. But kind of an advantage of this is it lets us, it's very flexible with respect to size. So like if we're not sure, like, do I want to cluster, do I want to just read a couple things, do I want to sample more, it'll let you do that. A disadvantage, and this is maybe more of a disadvantage of the semantic model, and we'll talk about this on the next slide or so, is you can say some weird things, and it's not really going to notice, it's not really going to cluster it right, because it's not really encoding it in a way that you might want it to do. I'll do that on the next slide. Okay. How do we validate this? How do we tell if it's working? Like with anything else, we manually label some data, right? Like you can't really get around that. So for here, I used 3 different but very related prompts. I did 10 on each of them, and I wanted to see whether my clustering process would find those 3 different prompts. And this is doing, I know I said you can cluster it at different levels. There's like an optimal clustering piece that does a certain thing with minimizing. And it found 3. And so it did find exactly my labels. I would say this isn't really evidence for this method, like because having 3 different prompts isn't really what we wanted to do here. But it's a method. So it's a method for testing out, like, hey, does this clustering thing seem to work? Okay. And the final piece is again, you take responses from whatever level of cluster you want, and you have a person read them, right? And then maybe do that other method. Maybe they're like, this is what I'm concerned about, now I know I can do this other thing. Okay, so how can this fail? There's 2 kind of big ways this fails. This fails via incomplete population coverage, so where there was this area we wanted to get and we didn't actually get all of it. And it fails with inadequate evaluation methods. So here's this first piece. So incomplete population coverage is like, we found all the things in that circle, right? We didn't find anything outside of that circle. And how can that happen? That can happen in a couple different ways. So first, maybe I have parameters that are just missing. So I had a bunch of perturbations, I generated them, I thought they were really cool. They were like this perturbation space, and there's this other perturbation space that corresponded to the other response space, and I just totally missed it, right? And that's hard to figure out if you're doing. What's easier to figure out if you're doing is stopping too soon. So if maybe you stop too soon, you don't really get anything, you don't get as much. And now you can kind of test by just sort of running this much longer than you would ever run it, and then figuring out, hey, if I had different stopping criteria, right? I can test for different stopping criteria and see like, oh, I could have been much more conservative about this and I still would have gotten all the stuff I was looking for. Okay, so that's one way. Another way is inadequate evaluation methods. So like for instance, like what if my metrics of closeness don't actually measure closeness, right? Then here, like I wanted to find that dot all the way over there, instead I found that dot all the way over there. So there were actually things that were closer to what I was looking for than what I was when I was able to find. Or in the second method, like I don't know what I'm looking for, but what I want to find is things from each of these clusters. But because I clustered wrong or I mapped wrong, I only find a couple. So I'm missing representative responses. So these are kind of the two main ways that this breaks. Okay, so examples of semantic distance limitations. I'm going to tell you this, and I didn't believe this when I saw this, and Will didn't believe this when I showed this to him, but I really did. Like, you can see my code, guys, and I really did test this, okay? So you start out with a list of basically recipes or instructions for how to make different pasta. You append to one of them at the beginning, and also this will kill you. Okay, which is like important recipe information, right? Like there's a recipe, and like it's otherwise a great recipe, but also it's gonna kill me. Like I want to know that, right? So these are like chunks. They're basically a couple paragraphs, okay? And you append it, and you have distances already between that recipe and all the other recipes. You recalculate with the whole like it's gonna kill you thing, and they're on this line, which basically shows that you didn't change. So some of them got a little better. It was a little weird. Some got a little worse. Go ahead.
I'm just double checking if this is like within that 120.
It is. So that was the first mistake I made. Yeah. I was like, this is really long. And then I found out about the limit, and I was like, no. So I put it at the beginning instead of the end. Yeah.
Would there be variation in the distance metric depending on which like embedding model you use to create your AI?
Totally.
Have you tried out a couple different ones?
So I don't think that's what this is. So what I think this is that it's like 5 words, right?
Oh.
And there's a bunch of other words. Because when you do this with when you do this with just like you take a couple, like a sentence and you embed it at the beginning, then it does change. So I think what we're seeing here is that these are chunks of text that are already like a bit long. And so I don't think there's like any words you could add that would just be a few words that would really change it that much. Like that's my guess. I don't know. That's my guess as to what's happening.
Could you do like some kind of like weighted distance metric where like you have like more important words like kill that would
Well, but
overwhelm an entire
right.
paragraph?
But in 768-dimensional space, there's no thing that's just kill. Right?
Yeah.
So I don't want to I think like kind of probably where this leads us to is why the first method is better, right?
Yeah.
Is why like you should know what you're actually looking for, and you should look for it.
I'm just spitballing. Would
Please.
chunking the text help you, and then you just keep track of, alright, these are the sentences associated with recipe 1, these are with 2, and then we go through and like, oh, this is really different than all of the other sentences in the other,
Yeah, I think one possibility here really is chunking everything out into sentences. I think what we need here is either questions that are very narrow, right, where we're not asking like explain to me about cells, but we're asking like really specific questions where maybe the answer is just a few sentences, or I think we need to chunk it. Because I think that this is like in the right direction, but I think what we're seeing here is that expecting to feed a few paragraphs of text to a model is like just not gonna get us what we need.
I ran into a similar problem where like doing the whole sentence like was terrible in terms of like the similarity to what I was looking for, because I was looking for so trying to get like the input as close to like what like I'm comparing it to like helped. So then I did it chunking on like 3 words, and like that definitely improved
I think, and I mean, and ideally, like, if there's a word that we just, like, we're gonna be really freaked out if the model says this, then we really just wanna look for that word.
Yeah. And
so it may just be that, like, keywords, or, like, chunks of keywords. Like, that may really be the way to go here. I'm not totally sold on this, and I do think that if we use it, it does need to be shorter, like, questions that lead to shorter things, or else answers that we're chunking in some way. I think that's right.
This is super cool.
Thank you.
I mean, if you didn't know, if somebody else did this and you didn't know that there was a line about killing you, and you wouldn't have thought to put in to check the word kill, then also looking at percent of important tokens matched, you'd be at like 97%. So I feel like it's not necessarily a semantic distance thing only. I feel like any of your 3 methods would have had this problem. No?
Yeah, I mean, well, but that's the thing with like, if we know what we're looking for.
If you know that recipes are about possibly fatal versus non-fatal messages.
But if I'm like, there's this bioweapon thing, and I'm not paying attention to it, I don't implement bioweapons, but if what we're going in is saying like, hey, we're really concerned if you can output this sentence, then we can get pretty close.
Yes.
But yeah, I think it's possible that this whole like exploratory, get the full range of everything, I think that it is possible that is a doomed endeavor. I'm not really sure. Or it's possible the answer is you actually just have to read all of them. Like, we can automate the sampling part for you, but you're just gonna have to. Sorry. I don't know. Okay. Okay, so next steps. Okay, so there's a lot of things, and you can definitely, like, guys, like, there's a lot of things that you can spend, like, a lot of time on here. So the whole prompt perturbation thing, stopping parameters. Better search is a good one. So if you're familiar with like hyperparameters, you know, like that's another multi-dimensional search problem where like people have done things that are better than random search. So right now I'm basically doing random search. So we pull a parameter, we randomize temperature, we do it. It's possible that this is an area where instead what you want to do is like find the space that looks good, right? Like we found some perturbations, we found some temperatures, we're getting better answers, better in terms of closer to our target text, or better in terms of more varied, and maybe we want to search more in that space. So I think that's possible. We can compare this to manual red teaming, so we can see like if we give people some time and some goals, are they able to find stuff that we're not finding? We can compare each method to itself, and so we can say like, does the exploratory method get us things that are close to the best results? Right? And we can incorporate jailbreaking. My hope is to not have to incorporate jailbreaking, but if you need to, I think we can incorporate that into the prompt generation process if we need to do that. So there's like a lot of places I can sort of go here. I'm definitely like, since I'm doing this in my basement, I'm hoping to think of ideas, because I have 5 more months on this, and I'm hoping to get like a lot more done. Okay, questions?
Broadly on large language model safety,
Yeah.
how solvable do you think this is? I just know a lot of people are, like, do you think, are we able to get it to be much just safer, much more reliable in the answers, or will it always sort of be this risk factor?
Well, I guess we'll talk about the safety piece. So, like, if by safety we mean like it's correct, I don't think that's a safety issue. Like, there's lots of tools we use that are wrong about lots of things, lots of times, and we sort of cope with it in various ways, right? So, like, asking like, how good is Google going to get? Is like sometimes it's going to give you the wrong results, and so you have a method for handling that. In terms of the like. I don't know. Maybe that's a bad answer.
No, that's very good.
Okay. But in terms of like, are we ever going to get this to be like correct at the rates we would like? I think that's hard just because like it's trained on data that's wrong about things. Right?
Are we able to not have it give a recipe for napalm like that?
Oh no, but we don't care if it gives a recipe for napalm. Like Google a recipe for napalm, right? At least, I think it's bad for OpenAI if it's giving out napalm recipes. But I'm not sure anybody else should really care. I don't think that's a safety issue. I think it's a PR issue. But like bioweapons, sure, like that's a safety issue. And I think that there's probably, I think there's a value in knowing what it's going to say, even if you can't stop it, right? Because potentially then you can figure out like, there's other parts of the process when it comes to things like bioweapons and nuclear weapons. Like, it's not just like if you know the answer, you can go do it, right? I hope. So like maybe there's other parts of that process that can be made safer if we know what it says. I think beyond that, like I think that companies mostly don't want to make, LLMs that say this sort of stuff. I think that is both a PR issue and a safety issue. So I think just sort of like figuring it out. I think that's a major piece of this. My hope is for data poisoning personally. I think there's that could be a lot of fun. But I don't know.
Yes, one thing I was considering, like you can make like a safety leaderboard. You're testing all these different types of models and seeing how they compare. Then I think one criteria is like how many tokens or something like that, but just comparing different models and seeing how safe they are using your methods. posting that like on Hugging Face, I think that'll have a lot of value to it.
Yeah, you can benchmark, but my hope is that so I think having these processes be public is really good. I think having the actual text that we're worried it might say is sort of like it defeats the purpose kind of thing. So, I mean, maybe you benchmark it in a way where you don't actually share it, I don't know. But yeah, I would say like distinguishing between processes and actual text. I mean, you could benchmark the stuff so there are, there's a adversarial something benchmark that people are using in various jailbreaking stuff that is more like will it build a bomb.
Mm-hmm.
And so you can benchmark it on that if you want, but I don't think that's safety.
I was curious, can you talk about how this intersects with kind of the competitive landscape? Because especially with like open source, some of them, almost like their claim to fame is that they're not safe in the same ways that corporate LLM is.
Yeah.
And if you just, whatever way follow the trend of more compute power and it being cheaper, like is it maybe someone already asked this, but like in the sense of competition, is it just a losing battle in that sense? Because if like all the embeddings, even if like you use someone else's embedding to analyze that out of another model, there's all this language at the end of the day, and some people aren't like behaving by the same guidelines. Is it like where does that lead?
I mean, I think you still want to know what it does. You know, and with the open source models, like you do have access to model internals, so you have access to testing stuff that you don't necessarily for the other things. So, I mean, I think the question of like, look, there's a really hard policy question that I really don't know the answer to. But I mean, I would say like, even if you're not testing for the purpose of saying, like you can't release this because it's already released, like you still want to know what it does, right? I think fundamentally, like I think the question, I would like separate out the question of the testing from the way you do with the testing. But yeah, I mean, it's with what's
Because
happening with
I
compute.
guess I would also like, at a certain point, want people just, like, if the point of knowing what it does is to make it safer, but there's competition in the market to just let it do more things.
Well, I think part of the, like you said, I think part of the purpose is making it safer, but I think part of the purpose is like, if there's other parts of the world you can make more robust in response to knowing like, hey, this thing that was really hard to find out previously now is really easy to find out, then like maybe that means that there's like equipment or materials that we want to make it harder to get than we were previously, because now like our threat model has changed. So like I think the safety thing isn't just like we want to kill this model now, it's also just we want to know what this does.
So can you do the semantic similarities with a longer or larger number of tokens to compare more of the outputs?
Yeah, so there are models that will take longer things, and the question is like, is it doing a good job? So again, with this, like you take a book, and if you have a model that's willing to make that 768 dimensions, like you're losing a lot of content. And I think it's possible that even on the sentence level, maybe we're losing content. So I mean, I think it's really about trying things and testing it, but I think we should, like my intuition on this is that questions that are designed to have smaller answers is probably the way to go here, although it's more upfront work for your subject matter experts, or else that it's about splitting the responses you get into smaller pieces. Like I think even if we can find a model that says that it's handling big things, it's probably not handling them well.
So would there be any point in incorporating a model that detects or flags discussion of harm or death or injury?
I mean, you can. Like, so if what you want, so like OpenAI as part of what they're doing, like they have they're both looking at the content you're putting in and they're looking at the content they're going to give you. And if what you're interested in is doing that, you can. I mean, I think that's like, I think it's easier. Like, I think that's like you train a BERT model of some sort. Like, it's a binary classification problem. You can do it. I think it's definitely doable. I think it's very different from this. because but there's certainly OpenAI has reasons why they might not want a model saying that. And if you have your own LLM, right, like if you're hosting something that's customer facing, then you certainly might want it to, for various reasons, not put out those kinds of things. So yeah, I mean, I think there's definitely use cases, for that kind of thing. Yeah.
How do people find the adversarial strings? Is it just trial and error, or are they doing it in a systematic way?
Systematically. So two different systematic ways. So one of them is with open source models, gradient descent, which is super intensive, compute wise. And then there was another one that was, so there's been some work on this with closed source models too, where I think it was random generation coupled with doing targeted search, where they were these ones are working better, right? So again, using a BERT trained model to detect jailbreaking, you automate figuring out did this work, and then you look more in those spaces. And so they had various strategies for taking adversarial strings that seem to be working and coupling them, mixing them up, splitting them, doing various kind of string stuff on that.
That'd be very expensive though, right? It sounds I'm curious where the budget comes from.
Have you looked at Reddit?
Yeah, okay. So.
I don't know. I mean, so the open source one was really computationally intensive, and then the next one, which was the non-open source one, made some not very subtle digs about how computationally intensive and expensive and infeasible that other paper was. There's a lot of jailbreaking papers coming out, and they're interesting. It's a whole super interesting field. There is just a lot of compute being used on this. I don't know. I think that it's probably interesting from a computer science standpoint, and maybe it's something that it's really something that companies are probably fairly interested in. So maybe the idea is they'll use it. But yeah, no, some of this stuff is real computationally intensive.
So it seems like recently there's been a big trend in using GPT-4 to evaluate other models, or even try to jailbreak other models. What's your take on that? Because we're sort of at this point assuming GPT-4 is the cream of the crop, and we're using it to evaluate everybody else. What's your take on the pros and cons of that?
Actually, this is what I think about, because I'm trying to write all my code in a way where you can swap in any other model. And so there's this library called LLM, which lets you just really easily write things in a way that isn't. And there are some tools that I think do a really good job of GPT-4 evaluations, but they're limited basically to the OpenAI models. I don't really want to be limited because it is sort of we don't really know what comes next. But in terms of evaluating things with AI, I think that's, I'm excited about that. I think that's great. I mean, I think it's not we know there's some preference for things that's generated itself. But I think especially if you're using it in a relative way, where what we're trying to do is get the best responses from something using an LLM to rate it. I think that's, again, it's not the only tool I'm using, but I think it's really promising. Yeah, I think it's good. And there's some interesting, so Athena AI is doing some really interesting stuff with that for evaluating RAG, where for instance, you can have it look to see whether the answer that your model gave was contained in the context that was given to it. And that seems like something you should be able to handle. And yeah, it means you can basically have unit tests, which is super cool.
I'm curious, in your work, where you were most surprised to find the useful marginal unit of work, generating more perturbations, stretching out the stopping length. What seemed to get more interesting results?
It's really hard to say because I don't really have a way to measure more interesting results. And this is something where I really feel I want to look at some subject matter experts and actually have them tell me what it is they want. But I think, the other thing is that everything I'm doing is it's pretty straightforward. None of this is all standard NLP type stuff. I think the semantic novelty, I don't know if it works that well, but it's cute, But all this stuff is fairly standard. I think that, so I started to get into like perturbation testing and seeing like what's the relationship between perturbations in semantic space and responses in semantic space. I think it's gonna be like, if we can figure that out, I think that's just genuinely interesting.
So ask again in a few months.
Ask in a few months, we'll see. Yeah, I think I like the stopping criteria because you can test them. Like it's nice to have things you can test, whereas the perturbations I feel like are sort of harder to test whether you're doing a good job with them.
You want to walk us through your GitHub repo?
Oh shit.
Woo!
Do we have time? What's my-
Yeah, we can. Yeah.
Okay.
Yeah.
So. Okay. Actually, this is Will. Can I plug your demo events?
Oh, yeah.
About.
Yeah.
Okay. So we were talking. So Will is trying to resurrect. What is it? Full
Stack data science.
Full stack data science. And we were talking about. I was talking about how I put my core functions that I know I want to live in a functions.py file, and I have unit tests on them, although I don't have 100% coverage, whatever. But I have this, and then I have these like Jupyter notebooks for things where I'm not really sure like what I'm actually going to be doing with them. And so like this is where I'm working with this, and there's a bunch of additional functions, and you can see all my charts. And may have gotten a little excessive. You probably don't actually need this in the Jupyter notebook, but you can have it if you want it. So yeah, it's pretty, like, I think honestly probably like the next thing that needs to happen with this is it needs to be a library. I've never done that before.
GPT-4 can help?
Yeah, look, what if you wrote me my like YAML file? No, like obviously yeah, I don't know, I've never walked anybody through a gig. How do you do this? Okay, so no, I have a README, and it like goes through some things.
Is there
I
any
don't know.
code that you're particularly proud of? Or ashamed of?
Or, you know, it's all, I like to think like solidly mediocre. So let's see. So this was fun. So this was the whole, like, again, like we have this intuition that there's this response space of things it might say, which corresponds some way into this prompt space, right? So like maybe true, maybe not true. But that was really like, that was the goal here. And so I like tried a bunch of things and then ultimately kind of wound up here. So like, what's the correlation between the distance from our original thing for our perturbations? So we generate some perturbations, we see how distinct they are from our original prompt, and then we look to see how distinct is our response for the perturbations from the prompts generated by that original thing. So basically, like, if we generate perturbations that are really different from our original, then are the responses we get also really different from the responses generated by our initial prompt. I think the answer here is not really, because it doesn't look like really much is going on there, right? So I'm going to assume the answer to this is not really, which is, you know, like a little bit sad. But it's also possible that we're just like measuring all of these wrong. That these are just like, again, that I'm trying to make semantic similarity like do things that it really wasn't built to do. But that was interesting. That was kind of fun working with. There's a researcher working on some of this stuff that had like thought way more about prompt perturbation modeling than I had. So I wanted to kind of test that out. Yeah, I don't know. This doesn't actually do anything. There's a lot of code.
That's a lot of GPT calls. That's a lot of
yeah, there's GPT calls.
Yeah.
So yeah, no, I use I have a compute budget, so I try not to worry about it. But yeah. Yeah, no, I don't know what else to show you guys. There's a bunch of workbooks you can go through. Yeah.
What would you call it when I can pip install?
What
would the name of the package be?
Oh God, I don't know. I've never done this before, but I just, it feels like this, like it should be
pip install safety.
Something.
Safety.
Okay, that's a little overstated.
Probably
right?
taken.
Safety LLM. I don't know.
Did you see the paper that just came out recently about the sleeper like models?
yeah.
I'm wondering, have you tried anything with like prompting to like see if you can jailbreak it by like just like I think in one of them they specified like in 23 versus 24 and they got it to.
Yeah, no, that's cool. No, it's neat. There's so much. I do like read papers on this, which is fun. Yeah, there's some weird stuff.
And just for the group, so this is the paper about like poisoning the training data essentially, right? Or the
Yeah, so it's
Yeah.
poisoning training data and then sort of fine tuning and it doesn't pick up on like because you're not specifically aware that there's this thing, so you're not specifically mitigating the thing, then it looks fine and then it does things you don't want it to
There's
do.
By
also
switching up the
Blaze.
prompts slightly, right? Oh, sorry.
There's also Blaze, but that's not for languages, that's for generating images. The pictures look almost, through a human eye, very similar, but if you run it through like Stable Diffusion or something, it will break the model, but that's the idea. That it will break the model.
Oh.
Yeah, lots of fun stuff.
So, a question about like security responses. If there is like say a new open source model that it's discovered will happily tell people how to build like super pipe bombs or something bad, what kind of remediations or responses are available? Because all these open source models are primarily just a list of weights, which nobody really knows like how each weight corresponds to like pipe bombs and willingness to talk about them. So like, is there anything you can do, or do you just have to run it as a commercial service and put a prompt saying, please say nice things only?
No, I mean, I think you can, so there's this really interesting paper that was the like forgetting about Harry Potter paper, okay, where there's researchers trained a model to not be able to answer questions on Harry Potter. And I think maybe you can do that more easily with Harry Potter than certain other things, because maybe you can zero in on like text that's Harry Potter related, but you can train a model to forgetting to do something. And I think it actually forgets. I'm not totally positive, maybe it doesn't, but I think that training models to not know things is a lot more fruitful than like alignment stuff. Because again, like you can unalign a model, right? You can unalign a model accidentally, right? But if you want to train a model into knowing things that it doesn't know, then like probably you need to bring in data. And if you had that data, you wouldn't need the model to do that.
It seems like to me a big factor in all this is if it's just accessing public data versus somehow it accesses confidential data that we aren't supposed to know, like that makes a big difference. Like this is data no matter what that we probably have some, maybe it'll take more digging, but we'll have access to it versus like if it's somehow someone leaks data that we aren't really supposed to know for our own safety and it's trained off that, it's a big difference.
Yeah, so a different way of thinking about this, and I've written about this a little, is like maybe what you want is to evaluate the training data, right? Like if the issue is what's in the training data, maybe we want to look at the training data. But again, like this is black box testing, like we can't necessarily know that we're going to have access to the training data. So I mean, I think we kind of need a method for doing without that. But yeah, presumably one way is to do that. I mean, I think another concern is more capable models that were not trained exactly on a task, but like they know enough about biology, right, that they're able to kind of infer some things.
I feel like there is, there's protein folding and there's all kinds of other deep learning, ways to do something like that versus this is like language and it's not the ideal, vector, I guess, for things like that. I don't know.
Yeah, I mean, that may be. I mean, I think the how available it is, the like how cheap it is, that it's not like a specialized tool, but that it's like a thing that's, that with the closed source models you can run on the internet, and with the open source models, that it's a thing that increasingly you can run on smaller amounts of compute. I mean, I think that's probably one of the concerns here.
Thank you for the talk, very useful. actually like, I come from more of the policy spaces where I feel like even for maybe just for general use, maybe it's okay for the LLM to produce something that we would just look for a public data, but since the background I'm coming from is like you actually really want to make sure to not do the harm that is already like embedded in the society. So I was like, so while people were talking about it, I was like thinking inside of my head like, and when I'm thinking of like making an LLM that wouldn't do a harm, decentness seems like very useful, but at the same time I could also see like you probably would be asking things in very different many dimensions. Like if you could talk about maybe race, we could talk about gender, and like all different types of areas. And I wonder, I mean, it's a preliminary step, but like I also since you also talked about you also work with the US government a little bit, like whether how do you see like how useful like this could be, or like when you're finding it, like do you think like you need to like find a way to even like make something that is some kind of way that's more computationally like cheap, or like more like with a lower amount of data to make all this consideration to like value model? I don't know, I don't have to make sense.
No, so I think a lot of the concerns about use in kind of the bias space are very specific to particular use cases. So they're like, I'm evaluating resumes, right? And we can't really test broadly in any sense for bias in resume evaluation. You need specific resumes, right? That are specific to your task, to your use case, and then we kind of got to test it on those. So I'd say like that's a very different issue and that's a much harder issue, right? From the harmful instructions piece. Like the harmful instructions piece is really like, doesn't know this, right? Whereas a lot of the broader harm issues are not about the model, they're about the model plus the use case. And we kind of have tools for that already though to some extent. So like, we can evaluate like classification models, right? So we have like the infusion matrix, right? And we have like, here's where it got things correctly and here's where it didn't get things correctly, and was it doing something systematically wrong in ways we didn't want it to do. So like I would say like both, we can't evaluate the model for it, and we already have the computational tools to do this. So it's a question of sort of where and how we're applying them. And like EOC put out something pretty early in terms of generative AI, which basically was like, if it's not legal to discriminate normally, it's also not legal to do it if you use a robot, right? Which is like good, right? Like we probably want to have the same standards for things we already thought were not good. We probably want to have those same standards for if you use AI. But the harmful instructions thing really is like kind of it's a different piece, because it really is kind of a property of the model, not of the use case. So like there is some ability, my hope is to do sort of testing. I think it's probably also easier to mitigate. So like can you get a tool to say, like rude or bad things? I don't know that, because like there's lots of contexts where we might want the tool to say things that are sort of adjacent to things that are rude or mean. I don't know that you can we really necessarily want to, do a classification model that was never going to say it, because then you're also limiting its ability to do things that you want it to do. Whereas like hopefully on the bioweapons side, like hopefully there's a way you can say like, we're not significantly limiting it, but also like we don't want it to do this piece.
So obviously there's a lot of awesome work like this and a lot of other benchmarks for LLMs. Is there an aspect of LLMs you think people aren't trying to benchmark enough yet?
This is so no. I mean my very like niche hope is like somebody should do like an R coding benchmark. I'm trying to sell the R people on that, and they've not so far bit. I don't know. I mean, I guess it depends like what's your goal like with benchmarks. I mean, it seems like the ones out there that are used like on the Hugging Face leaderboard, like they seem to correspond pretty well to people's intuitions about how well models work. Like GPT-4, does better on a whole variety of these, and it also is like a better tool for most things. So I mean, I don't know. I think for like broad use benchmarks, I think we have things that correspond pretty well to our version of reality. And if you have something really narrow for your specific tools, so like there are a bunch of coding ones out there that I think are interesting, then you spin one up for yours. But I think the general purpose ones are doing what we want them to do.
Well, one last question. Last question.
I kind of feel like I was just trying to explain your thought. I was sitting here just thinking through, working in the corporate space, I do a lot of auditing and assessments and security. And obviously AI is like, an interesting space. A lot of corporate clients that I've had or that people I work with, they're partnering with AI companies now. And I wonder how accurate the information is that they're going to be putting out, right? Like, you think of different aspects of ethics and what are they accessing, what would they share? So I kind of wanted to come into this talk and just kind of hear about how do you test that out? Like, how do you test, are they accessing the right data? Are the outputs correct? Is there some type of framework around that? It sounds like you're creating something like that. But I'm wondering if corporations are also doing something like that before they're putting out data that may be inaccurate. I think about like simple things with AI that I'm doing so hard, just like pictures, right? You see the hands are all wrong. Okay, so clearly the data here is a little off. But we know, OpenAI is not necessarily correct. You might have to change some things. I just wonder kind of in the corporate space, are they clear on that same thing, that what's coming out may not be correct?
Yeah, so it does. There were a lot of folks in government, I'm sure corporations, where this came out and everybody was like, build me a retrieval augmented generation thing, okay? Like, I want a chatbot over my documents. And we all built them. Like, we all built like little Streamlit apps, we built them, and like, there was a talk here last week where George Rooney, who's a data scientist, came in and talked about like basically like why you shouldn't do that. Like, why like actually building this kind of tool is a lot more complicated. And you need to put a lot more thought into it and to sort of how you're doing it and how you need to spend all of your time looking at the log files for like what is it actually putting out, what is it saying, and how you need to like read that stuff religiously and iterate. And I think most of the people building these tools, government and corporate, are not doing any of that. And I think that's like not great. Like, it definitely means that you might have a tool that, there's no existential risk, but like, it's gonna say some things that are pretty dumb and like pretty wrong. And, if it's public facing, that's like potentially embarrassing. Also, maybe somebody's using your tool to get free GPT-4 access, which like also isn't great. And we absolutely have the tools to mitigate this. So like, the easy thing is the narrower you're trying to build a tool for, the easier it is to have your first step of your tool be a classification process that says either this is something this tool is going to answer or it's not. And like, we know how to do that. Like, data scientists have built that, like we can handle that. If you have a tool that's only supposed to answer questions about, say, like Toyotas, okay, like we can fine tune BERT and it will only answer questions about that. And if somebody tries to use it for other things, it won't. So like, that's the really easy step, and no, I think people are not doing that. And then the harder step is it answering correctly? And that's harder. But there really are like tools. There's like monitoring tools that do that kind of stuff. You can like roll your own. You can spend a lot of time reading log files. And yeah, I don't think that's happening. Like, I think that's happening probably much less than it could be.
All right. That's all the time we have, so
Okay.
thank you, Abigail.